Yes, it is possible to run a 200 amp service through the basement and across to the back unit. However, there are several requirements that must be met according to the National Electrical Code, or NEC. Firstly, the conductors must be installed in a raceway, such as a conduit or cable tray. Secondly, the raceway must be securely supported and protected from physical damage. Thirdly, the raceway must be sized to accommodate the number and size of conductors. Fourthly, the conductors must be properly terminated and secured at all connections. Now let's delve into NEC section 230.3, which addresses multiwire branch circuits. NEC 230.3 covers circuits of 2 or more phase conductors and 1 neutral conductor. It states that 2-wire branch circuits shall be permitted to supply 2 or more outlets or devices provided the outlets or devices are connected in parallel and the ampacity of the circuit is in accordance with 210.21 bone. Such circuits shall be permitted to be designated as single-phase 2-wire branch circuits. NEC 230.3b addresses circuits of 3 or more phase conductors and a neutral conductor. 3-wire branch circuits shall be permitted to supply 2 or more outlets or devices provided the outlets or devices are connected in parallel and the ampacity of the circuit is in accordance with 210.21 bone. Such circuits shall be permitted to be designated as single-phase 3-wire branch circuits. NEC 230.3c discusses circuits of 2 or more phase conductors and 2 neutral conductors. 4-wire branch circuits shall be permitted to supply 2 or more outlets or devices provided the outlets or devices are connected in parallel and the ampacity of the circuit is in accordance with 210.21 bone. Such circuits shall be permitted to be designated as 2-phase 4-wire branch circuits. NEC 230.3d covers circuits of 3 or more phase conductors and 2 neutral conductors. 5-wire branch circuits shall be permitted to supply 2 or more outlets or devices provided the outlets or devices are connected in parallel and the ampacity of the circuit is in accordance with 210.21 bone. Such circuits shall be permitted to be designated as 3-phase 5-wire branch circuits. Finally, NEC 230.3e addresses neutral conductors. The neutral conductor of a multiwire branch circuit shall be white or natural gray in color and shall be identified as a neutral conductor. The use of the white or natural gray color shall not be permitted on any conductor other than a neutral conductor. When running a 200 amp service, ensuring proper conductor sizing is critical. This involves consulting NEC Table 310.15b16 or other relevant tables to determine the appropriate conductor size based on the ampacity and the insulation type. For example, if using copper THHN conductors and assuming an ambient temperature of 30 degrees Celsius, you might need 3/0 AWG conductors for a 200 amp service. However, this is just an example, and the actual size must be calculated according to the specific conditions of the installation, including directing factors for conduit fill and ambient temperature. The raceway type also influences the choice of conductors. For instance, if using rigid metal conduit (RMC) or intermediate metal conduit (IMC), you can typically use THHN or THWN conductors. For underground installations in conduit, you might opt for conductors with a wet location rating such as XHHW. Ensure the raceway is adequately sized to accommodate the conductors, referring to NEC Chapter 9 tables for conduit fill calculations. The NEC specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. Proper termination is paramount for a safe and reliable electrical service. Use appropriately rated connectors and lugs for the conductor size and material. Ensure connections are torqued to the manufacturer's specifications to prevent loose connections, which can lead to overheating and potential fire hazards. When transitioning from the main building to the back unit, consider using expansion fittings in the raceway if there's a possibility of significant movement between the buildings due to settling or thermal expansion. Expansion fittings allow the raceway to expand and contract without putting stress on the conductors or the raceway system. Also, carefully seal the raceway where it enters each building to prevent the ingress of moisture, rodents, or other pests. Use appropriate sealing compounds or fittings designed for this purpose. Grounding is an essential aspect of electrical safety. Ensure the 200 amp service has a properly sized grounding electrode conductor connected to a suitable grounding electrode system, such as a ground rod, ground ring, or connection to the building's metal water pipe if permitted by the NEC. The grounding electrode conductor size is based on the size of the service entrance conductors, as specified in NEC Table 250.66. Additionally, a bonding jumper should be installed between the neutral conductor and the equipment grounding conductor at the service entrance to establish a low impedance path for fault current. Overcurrent protection is another critical safety measure. Install a 200 amp main breaker in the service equipment to protect the conductors from overloads and short circuits. The breaker should be rated for the voltage and ampacity of the service. Also, consider using surge protection devices, SPDs, to protect sensitive electronic equipment from voltage surges caused by lightning or other transient events. SPD should be installed at the service entrance and possibly at downstream panels to provide comprehensive surge protection. When running the 200 amp service through the basement, ensure the raceway is adequately supported to prevent sagging or displacement. Use appropriate hangers, straps, or clamps to secure the raceway to the building structure. The spacing between supports should comply with NEC requirements for the specific type of raceway being used. Also, protect the raceway from physical damage by installing it in locations where it's not likely to be struck or damaged by vehicles, equipment, or other objects. If necessary, use physical barriers or guards to provide additional protection. Before commencing the installation, obtain the necessary permits from the local electrical inspection authority. The inspector will review the plans and inspect the installation to ensure it complies with the NEC and local codes. It's also a good idea to consult with a qualified electrical engineer or contractor to ensure the installation is properly designed and executed. They can provide valuable expertise and guidance to ensure a safe and reliable electrical service. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is essential to consult the latest edition of the NEC and any applicable local codes before commencing any electrical work. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable performing the work yourself, hire a qualified electrician to do it for you. They have the training, experience, and equipment necessary to perform the work safely and correctly. Firstly, review all applicable NEC requirements and local codes. Secondly, obtain the necessary permits and approvals. Thirdly, plan the installation carefully, considering all factors such as conductor size, raceway type, termination methods, and grounding requirements. Fourthly, use high-quality materials and equipment that are listed or labeled for their intended use. Fifthly, follow manufacturer's instructions for installation and maintenance. Sixthly, perform thorough testing and inspection after the installation is complete to ensure it is safe and reliable. Seventhly, maintain accurate records of the installation, including plans, specifications, and test results. Eighthly, provide adequate training to personnel who will be operating or maintaining the electrical equipment. Ninthly, implement a regular maintenance program to ensure the electrical system continues to operate safely and efficiently. Tenthly, stay up to date on the latest changes to the NEC and other relevant standards. When working with electrical systems, always de-energize the circuit before commencing any work. Use appropriate lockout/tagout procedures to prevent accidental re-energization. Wear appropriate personal protective equipment (PPE), such as insulated gloves, safety glasses, and arc-rated clothing. Use insulated tools to prevent accidental contact with live circuits. Work in a well-lit and ventilated area. Avoid working alone and have someone nearby who can assist you in case of an emergency. If you're not sure about something, ask for help from a qualified electrician or engineer. Never take shortcuts or compromise on safety. Electrical safety is everyone's responsibility. By following these guidelines, you can help prevent electrical accidents and ensure a safe working environment. Always remember to prioritize safety above all else when working with electricity. Understanding the specifics of NEC 210.21 BOM, which is referenced within NEC 230.3, provides further context. NEC 210.21 BOM deals with the overcurrent protection of multi-outlet branch circuits. Specifically, it dictates that the rating of the overcurrent device protecting a branch circuit shall not exceed the ampacity of the branch circuit conductors. This means the circuit breaker or fuse protecting the 200 amp service must be appropriately sized to protect the conductors supplying the load in the back unit, typically 200 amps. This section also includes stipulations about the type of receptacles that can be installed on certain branch circuits based on their ampacity. It's essential to ensure the overcurrent protection is correctly sized to prevent overloading the circuit and potentially causing a fire. When determining the conductor ampacity, it's critical to consider derating factors. Derating factors are adjustments made to the allowable ampacity of conductors to account for factors such as ambient temperature, the number of conductors in a raceway, and the type of insulation. For example, if the ambient temperature in the basement is higher than 30 degrees Celsius, the conductor ampacity must be derated according to NEC Table 310.15 beta. Similarly, if there are more than 3 current-carrying conductors in a raceway, the conductor ampacity must be derated according to NEC Table 310.15 B3. The derating factors can significantly reduce the allowable ampacity of conductors, so it's essential to account for them when selecting the appropriate conductor size. In addition to the general requirements for running a 200 amp service, there may be specific requirements that apply to the particular type of occupancy or application. For example, if the back unit is a dwelling unit, there may be additional requirements for ground fault circuit interrupter, or GFCI, protection, or arc fault circuit interrupter, or FSI protection. If the back unit is a commercial building, there may be additional requirements for emergency lighting or fire alarm systems. It's essential to consult the applicable sections of the NEC and any local codes to ensure the installation complies with all applicable requirements. The distance between the front unit and the back unit, approximately 20 feet, is also a factor to consider. Although this distance is relatively short, it's still important to ensure the conductors are adequately protected from physical damage and environmental factors. If the raceway is exposed to direct sunlight, it may be necessary to use conductors with a sunlight-resistant insulation. If the raceway is exposed to corrosive environments, it may be necessary to use a corrosion-resistant raceway material. Also, consider the potential for future changes or expansions. It may be wise to install a larger raceway than is currently needed to accommodate future wiring needs. This can save time and money in the long run if the electrical system needs to be upgraded or expanded. The choice of service entrance equipment is also an important consideration. This service entrance equipment includes the main breaker, the meter, and the associated wiring and enclosures. The service entrance equipment must be rated for the voltage and ampacity of the service and must be suitable for the environment in which it is installed. If the service entrance equipment is located outdoors, it must be weatherproof. If the service entrance equipment is located indoors, it must be protected from physical damage. Also, consider the accessibility of the service entrance equipment. The service entrance equipment should be located in a readily accessible location so that it can be easily inspected and maintained. In summary, running a 200 amp service to a separate building requires careful planning and attention to detail. It's essential to consult the latest edition of the NEC and any applicable local codes to ensure the installation complies with all applicable requirements. It's also a good idea to consult with a qualified electrical engineer or contractor to ensure the installation is properly designed and executed. By following these guidelines, you can ensure a safe and reliable electrical service for the back unit.